In this video, we are going to do exercise 4.5. This exercise deals with adjoint of a matrix, its properties, inverse of the matrix by determinant method, and characteristic equation of the matrix. Now this video is going to be a bit long. If you get tired easily, after every 15 minutes, you pause the video, take some rest and watch the video again. Also, always keep your NCERT and your notebook with yourself. Try to do question by yourself once you understand the concept, and if you are unable to do, only then watch the solution. This is the right way of learning online. Right, let us start. So this is a 2 by 2 matrix, and in the question they have asked us to find adjoint of this matrix. So adjoint of a matrix is a matrix itself. Okay, the complete definition is adjoint of a matrix is the matrix which is transpose of the matrix formed by the cofactors of the given matrix. Right, so definition is a bit difficult to understand, but once I'll explain, you will get everything easily. See, if I hide this element 1 by column and row, the element which is left with us is the minor 1 1. So I've written minor 1 1. Now if I hide this element a12 with row and column, I have minor 1 2, that is 3. Now if I hide this element a21 with row and column, I have the minor 2 1, which is 2. And if I hide this element a22 by row and column, I have this element 1 as minor 2 2. So this method of finding minors we have learnt in exercise 4.4. So once you have got these minors, how to find cofactors? Very easy. If the sum of these numbers is even, the cofactor will be same as the minor. And if the sum of these numbers is odd, the cofactor will have opposite sign. That is, the cofactor 1 2 will be minus 3. So minor 1 2 is 3, but cofactor 1 2 will be minus 3. And similarly, cofactor 2 1 will be minus 2. Cofactor 2 2 will be same again because the sum of these numbers is even. So always once you find the minors, you simply change the sign of m12 and m21 and you will get the cofactors. So the cofactors are 4 minus 3 minus 2 1. Right. So we have computed the cofactors. Now what you need to do is make a matrix and write the cofactors like this: a11, a12, a21, a22. Generally, how we write the elements: 1 1, 1 2, 2 1 and 2 2, isn't it? When we write some elements in a matrix, it is in the form 1 1 1 2 2 1 2 2. But here, while writing the adjoint, you need to write the cofactors in this form: 1 1 1 2, 2 1 2 2. Therefore, I said adjoint A is the transpose of a matrix formed by the cofactors of the elements of a matrix. Okay, so once you find the cofactors, you arrange those cofactors in this manner: 1 1 1 2 1 3, like this, 2 1 2 2 2 3, and 3 1 3 2 3 3. Okay, fine. Now let us come to question number 2. It is a 3 by 3 matrix. So first of all, we have to find its 9 cofactors. So once you find the minors, it will be very easy to find cofactors also. And once you find the cofactors, just arrange them in this manner, changing rows to column. Like row would be a11, a12, a13. Instead of that, I am writing it in column. Right. Similarly, a21, a22, a23, a31, a32, a33. So once you find the minors, everything is very easy. Okay, let us see. Hiding this element a11 by row and by column, I'll get 3501. See, 3501. And on solving it, the minor will be 3 minus 0. I'm talking about minors. So if you already know the answer, don't just try to find the mistakes, right? Because now while finding minors, I'll not be putting the plus minus sign. Once I find all the minors, then only I'll put plus minus sign according to sign convention. So this is M11 that I have computed. Now I'll hide this element by row and column, that is A12, right? Hiding it with row and column, I'll get 2, 5 minus 2, 1. You can see here also. So 2 ones are 2, minus 10, that is plus 10, it will be 12. So I'm writing minor 1, 2 as 12. I'm not finding cofactor right now, right? Now I'll hide this 2 by row and column, and I'm left with 2, 3 minus 2, 0. It will be 0 minus 6, that is plus 6, and the minor 1, 3 is 6. Got it? Right. Now this minor. So hiding this element A21 by column and row, I have minus 1, 2, 0, 1. Solving it, I'll get minus 1, minus 0, that will be minus 1 only. So this is the minor 2, 1. Minor 2, 1 is minus 1. Here it is 1 because he is calculating cofactor. I am finding minors, right? Once I write all the minors, then I'll change their signs according to the sign convention, and then I'll get my cofactors also. So hiding this 3 by row and column, I get 1, 2, minus 2, 1. Solving it, 1 minus 4, that is plus 4. 1 plus 4 is 5. Minor 2, 2 is 5. Now minor 2, 3, I am hiding this element by column and row. I have 0, minus 2. 0 minus 2 is minus 2. Minor 2, 3, minus 2. Now minor 3, 1, hiding this element by column and row. Minus 5, minus 6, that is minus 11. Minus 11. Minor 3, 1. Hiding this one by row and column, I'll get 1, 2, 2, 5, that is 5 minus 4. 5 minus 4 is 1 again. And now hiding this element by column and row, minor 3, 3 will be 3 plus 2, 5. So these are just minors arranged in a proper manner, right? Now how to find cofactors quickly? Cofactors would be, you just change the sign of this element, this element, this element, and this element. You will find cofactors. Remaining will be same. Why? Because see, this cofactor of this position, right, it is actually A12. So A12 means 1 plus 2, 3. The sum is odd. Therefore, the sign must be changed. This is A21. A21. 2 plus 1 is 3. Odd. It means the sign should be changed. Then this term, it is A23. Right. Second row, third column. A23. 2 plus 3 is 5. 5 odd means the sign should be changed to find the cofactor. And then this element, it is 3, 2. 3, 2 means 3 plus 2, 5 odd. Again, the sign must be changed while finding the cofactors. And these are even only, like A11, 1 plus 1, 2. A13, 1 plus 3, 4. A22, 4. A31, 4. A33, 6. So no change in sign for these elements. So this cofactor will be minus 12, and this one will be plus 1. I'll just remove this negative. Okay, this will be plus 2. So plus 1, right? And here just a negative need to be put. Got it? So the first cofactor is 3, second is minus 12, third is 6. Next we'll see 1, correct, 5, correct, 2, correct, then minus 11, minus 1, 5, minus 11, minus 1, 5, right? So instead of doing this long process, simply find minors M11, M12, M13, M21, M22, M23, M31, M32, M33. Once you find the minors, these elements, you change the sign. I explained you the reason. And this is the sign convention. If you want to memorize the sign convention, that also you can memorize. Minus, minus, minus means these element, the sign should be changed, right? So once you find the cofactors, okay, This is A11, A12, A13, then A21, A22, A23, then A31, A32, A33. What will be the adjoint? In adjoint, you will write A11, A12, A13 in the first column, then A21, A22, A23 in the second column, and A31, A32, A33 in the third column. That is making row into column, and you will get adjoint, right? So what will be the first column? According to us, it will be 3 minus 12, 6. Let us see. 3 minus 12, 6. Next column will be, according to us, 152. So 152, and the third one, it is minus 11, minus 1, 5. I hope you got it, right? Okay, so let us proceed to question number 3. Something new to learn. Whenever you multiply A with adjoint A, or adjoint A with A, it is always equal to determinant A into I for any matrix, and we have to verify this for this matrix. Always remember, A into adjoint A and adjoint A into A both are equal to determinant A into I is identity matrix. Let us see. So first of all, what is this term? This is determinant A into I. Determinant A. Determinant A will be minus 12. And this is minus 12, we have to change its sign, that will be plus 12. So minus 12 plus 12, that is 0. So determinant A is 0. And 0 into identity matrix, 0 into identity matrix is 0 also. Why we have taken identity matrix of 2 by 2 order? Because the question is in 2 by 2 form. So if the question is 3 by 3, the identity will be 3 by 3, right? Okay, so this determinant A is 0 and 0 into I will be 0. So it is a null matrix or 0 matrix. Now let us see what is A into adjoint A and adjoint A into A. If all these three terms are equal, then our question is done. Okay. So first of all, minor for this 2 will be minus 6. Minor for this 3 will be, hiding it, minus 4. First I am writing in the correct order, and these are minus only, then later I'll change the signs according to sign convention, and then we'll get the cofactors. Okay, hiding this minus 4 by column and row, we'll get 3 as the minor, and then hiding this minus 6 by column and row, I'll get 2 as minor. And now I need to change the sign, as I've already told you in question number 1. In 2 by 2 matrix, these two signs will be changed to find the cofactor, right? So whatever is negative, we have to change it in positive, and if it is positive, we'll change it into negative. So once you have find the cofactor, now we can find adjoint A. And how to find adjoint A? Simply write this first row of cofactors into first column. Yes, you can see first row into first column, and second row of cofactors into second column, and just put it in a box, that is in a matrix, and this is our adjoint A, as we have already learnt. So A into adjoint A will find A is this and adjoint A is here. Simply we'll multiply. Don't forget the old things while doing the new things. Multiplication is done by row into column. 2 into minus 6 is minus 12, 3 into 4 is 12. Then multiplying this same row with second column, 2 into minus 3 is minus 6, and 3 2s is 6. Once the first row is multiplied with both the columns, now we can multiply the second row with both the columns. So minus 4 into minus 6 is 24, minus 6 into 4 is minus 24. Then minus 4 into minus 3 is 12, and minus 6 into 2 is minus 12. And now we have minus 12 plus 12, that is 0. This is 0, this is 0, this is 0. So A into adjoint is also a null matrix. So this thing is a null matrix. This is also a null matrix. Let us calculate this now. Adjoint A into A. So adjoint A into A, same method you follow. I don't think you need any further explanations. Just multiply, you'll get 0 0 0 0, and hence it is verified. So always keep this relation in your mind. Okay, so it will lead us to the method to find A inverse by determinant method. Okay. Again, the same question for a 3 by 3 matrix. I'll not be explaining it. Do it by yourself. That is our motive, that you learn by doing. Okay. So you can just pause it if you are unable to do it. Just pause it and see the solution. Right. So I'll not explain it. Let us move to the next question. Right. So for a 3 by 3 determinant also, matrix also, A into adjoint A into A is always equal to determinant A into I. Right. Okay. So question number 6. Find the inverse of each of the matrices if it exists. So it is not necessary that for a matrix always inverse exists. We have seen in exercise 3.4 that for some questions, some matrices, inverse did not exist at that time, right? So now we'll learn something more about the inverse. So as we have learned here that A into adjoint A is equal to determinant A into I. Okay? A into adjoint A into determinant A is equal to I. Okay. Now I'll take this determinant A towards LHS. What we'll get? We'll get 1 upon determinant A into adjoint A into A is equal to I. Okay. So what we have learned in the definition of A inverse. The definition says if any matrix multiplied, pre-multiplied or post-multiplied with A, it gives answer identity matrix, then that matrix is the inverse of A. Okay, so this is the basic definition of inverse matrix. If any matrix multiplied by A gives the answer identity matrix, then that matrix is inverse of matrix A. So by the definition, this whole thing must be the inverse of A. Now we'll apply this knowledge and find A inverse for the matrices. Question number 6. Find the inverse of this matrix. So what I'll do, first of all, I'll find determinant A. Minus 2 plus 15, that is 13. Determinant A is 13, right? Second thing I need is adjoint A. How to find adjoint A? First of all, find minus. By hiding this minus 1, column and row, minus 1, 1 is 2. Then hiding this element, row and column, minor is minus 3. And I am writing in same order as usual. Then hiding this minus 3, I'll get minor 2, 1, which is 5. And by hiding this element by row and column, I'll get minor 2, 2, that is minus 1. And now by changing the sign of these two elements, as already told, negative will become positive, positive will become negative, right? So these are the cofactors, cofactor 1, 1, 1, 2, 2, 1, 2, 2. And how to find adjoint A? Just write first row into first column and second row, that is minus 3, 2 into, minus 5, minus 1 into second column. So this is adjoint A. And then by the formula, what is A inverse? It is 1 by determinant A into adjoint A. That's it. You got the answer. So let us say if you get determinant A is equal to 0. If you get determinant A equal to 0, then you will not be able to find A inverse, right? Because 1 upon 0 does not exist. So A inverse does not exist. Okay. Other thing, there is a shortcut of finding A inverse for a 2 by 2 matrix. And what is that shortcut? Simply, first of all, determinant you have to compute. Determinant is 13. So just write 1 by 13. 1 by determinant. Right. And then for these two elements, just change the position. That is, whatever is written here, take it to this point, and whatever is written here, take it here. So 2 will be written here in place of A11 and -1 will be written here in place of A22. Right? Change of position. And for these elements, change their sign. So if it is negative, make it positive. If it is positive, make it negative. So this is the shortcut of finding inverse for a 2 by 2 matrix. For this diagonal, change the position of the elements, and for this diagonal, change the sign of the elements, and in front of matrix write 1 upon determinant A that you have to compute. So this method is good for 2 by 2 matrices. Okay, question number 7. Find the inverse of each of the matrices. Now it is a 3 by 3 matrix. First of all, the method is same, 1 by determinant A into adjoint A. What is determinant A? Let us see. So I can compute determinant by column as well and row as well, right? So if I am computing it with column, what will happen? This one I will write, then simply hide this one by row and column and you'll get 10 minus 0, that is 10, isn't it? And then for this 0, you need not do any calculation because 0 into anything is 0, and then this 0 again you need not do any calculation for this 0 because again 0 into anything will be 0. The determinant is 10. Hereby first row the determinant has been calculated. In both cases the answer will be same. So determinant is 10, right? So now we'll put our efforts in finding what? Minors and cofactors, so that we can easily find adjoint. Okay. So this is being a bit stubborn, right? So first minor 1 1. For that I'll hide this element by column and row. So I'll get 2 4 0 5. So 10 minus 0 is 10. Minor 1 1 10. Then I'll hide this element by column and row. 0 4 0 5. 0 minus 0. Answer will be 0. Then we'll hide this 3. 0 minus 0, that is 0. I'm finding minors as usual first, then I'll change the sign to find the cofactors. Now comes second row. Hiding this 2 1 by row and column, I'm left with 2 3 0 5. 2 5s are 10, minus 0, this will be 10. Hiding this 2 by row and column, I'll get 5 minus 0 and this is 5. Then hiding this 4 by row and column, I have 1 2 0 0, 1 into 0 0, 2 into 0 0, 0 minus 0 is 0. So let us do the same for third row. Hiding this with row and column, now I have 2 4s are 8 minus 6, that is 2. Hiding this 0 by row and column, 4 minus 0, that is 4. And now hiding this 5 by row and column, I have 2 minus 0, that is 2. So if I am going a bit fast, you need to see the previous things again, right? Okay, once we have got the minors, I need to change the sign of this element, this element, this element, and this element. So zeros are neutral, no need to put negative in front of them. 10 is positive, so I'll just put a negative. 4 is positive, I'll just put a negative, right? So this is A11, A12, A13, A21, A22, A23, A31, A32, A33. Capital A means cofactors. All the cofactors I have calculated. Now what is adjoint? Just put this first row 10 0 0 in first column, second row minus 10 5 0 in second column, and third row 2 minus 4 2 in third column. This is your adjoint A. And what is A inverse? 1 by determinant A into adjoint A. That's it. I hope it is clear. And then this question, again let us do it. Then after this question I will not find A inverse for you, then you can find by yourself. Okay, so let us say first of all we need to find determinant A. So determinant A I'll find with first row. So I wrote 1, and by hiding this 1 I'll get minus 3 minus 0, that will be minus 3 only, and I'll not do any calculation for this 0. And then again I'll not do any calculation for this 0, no expansion. So the answer will be minus 3. So it is always good to find determinant by that row in which maximum number of zeros are there to avoid too much calculation, right? Then minus. So first minor, hide this one by row and column and we'll get minus 3 minus 0, that is minus 3. Then hide this 0 by row and column, then I'll get minus 3 minus 0, again minus 3. Minus I am calculating. Now hide this 0 by column and row, I'll get 6 minus 15. 6 minus 15 is minus 9. Okay, up to this point it is clear. Okay, now hide this 3, row and column. 0 0 2 minus 1, 0 minus 0, that is 0 only. Hide this 3 by row and column. Minus 1 minus 0, that is minus 1 only. Hide this 0 by row and column, so 2 minus 0, that is 2. Now third row, hide this 5 by column and row. 0 minus 0, that is 0. Hiding this 2 by row and column. 0 minus 0 is 0. Hiding this minus 1 by column and row. 3 minus 0 is 3. Now I'll change the sign of those 4 elements. Plus, this is neutral, no need to change. This is neutral, no need to change. Plus means I'll make it negative. And now adjoint is, write first row as first column, second row as second column, and third row as third column. Okay? And A inverse is 1 by determinant A, adjoint A, very simple. Okay, find the inverse of each of the matrices if it exists. Now this one you will do by yourself. I'll just show you the solution once, and by pausing you can check it by yourself, right? And before checking you try to do it by yourself. Okay, just don't copy and paste it. That is a really bad idea to learn mathematics. Similarly, this question, let's not waste our time. This is the matrix, find the determinant and then find the cofactors. And once you find the cofactors, then A inverse is 1 by determinant A, adjoint A. Okay, this much you will be wanting me to do because trigonometry is there and most of the time students are scared of trigonometric questions, right? Okay, so first of all determinant. So I'll just write this one and hiding this one by column and row, minus cos square minus sine square, right? Taking negative common, cos square plus sine square, that will be 1, so minus 1. So determinant is minus 1. That is not a problem. And for other 0 0 we need not calculate anything. Now we'll focus on the minor, right? So hiding this one by column and row, I'll get minus cos square, then minus sine square, right? And minus cos square minus sine square is minus 1, as already we have seen here. Now hiding this 0 by row and column, this are remaining. 0 into minus cos alpha 0, minus 0 into sine alpha, that is also 0. So this element will be 0. Minor 1 2 is 0. Hiding this 0 by column and row. Now 0 into sine alpha is 0, minus cos alpha into 0 is 0. So 0 minus 0 is 0. Right? Now M21, hiding this 0 by column and row and check again 0 0 sine alpha minus cos alpha, this will be 0. Hiding this cos alpha by row and column, I'll have 1 0 0 minus cos alpha, and on solving I'll get minus cos alpha minus 0. So I'll just write here minus cos alpha. Right. On hiding this cos alpha or a whatever it is, hiding this sine alpha with row and column, I'll get sine alpha minus 0. So I'll just write sine alpha here. Sine A it is, I guess. So I'll write sine A, not alpha. Here also A it is. Okay. Now we'll hide this 0 by column and row, and what I'll get? 0 minus 0. Hiding this sin A by row and column, I'll get 1 0 0 sin alpha. So sin alpha minus 0. Again I'm saying sin alpha, excuse me, it is sin A. And then hiding this minus cos A by column and row. So cos A minus 0, it will be cos A. So these are just minors, and I'll change the cos A. I'll just change the sign of these four elements. These two are neutrals, 0 0, so no need to change the sign. Here I'll put negative because it is positive. Here I'll put negative because it is positive. So sign changed. And then adjoint will be, write first row as first column. Let us see, minus 1 0 0, correct. Then second row, that is 0 minus cos alpha minus sin alpha, correct. And minus 0 minus sin A cos A, correct. So this is adjoint A. So A inverse is 1 upon determinant A adjoint A. 1 upon determinant A is minus 1 itself, and adjoint A is this whole thing. Already we have seen how we got it. And now simply multiply this minus 1 with this whole matrix and you'll get the adjoint A. Okay. So simple it is. Next, this is a property. This kind of thing we have already learned in transpose of a matrix, that AB transpose is B transpose A transpose. Similarly, AB inverse is B inverse A inverse. So we have to verify it. Okay, simply what we'll do, first of all, we need to find A determinant, that is 15 minus 14, that is 1, right? So while finding A inverse, I'll not follow that same old method, because for a 2 by 2 matrix I know the shortcut, and the shortcut is A inverse is equal to 1 upon determinant A, that is 1 by 1. You can avoid writing 1 by 1, it feels very strange. And see, I'm putting straight lines, but it is curving it. I don't know what is wrong with the software, but still. Okay. So how to find the adjoint A? We have learned the shortcut. What I have told you, for this diagonal, change the position. So 5 will come here and 3 will come here, and change the sign for these elements. Position will not be changed, only sign. So by this method you can find inverse of a 2 by 2 matrix, right? This is the inverse C. Same. Yeah, you can do this. Don't think that we can't do this in CBSE exam. For 2 by 2 matrix you can do like this also. And for matrix B again, it is 54 minus 8 7s are 56. So minus 2. So 1 upon minus 2, and then change the position, that is 9 will come here, 6 will come here, and this will be negative, this will be negative, right? So here it is, minus 1 by 2, change the position, change the sign, okay? And what has been done here, this 2 we have taken inside the matrix, multiplied by everything, that is half is multiplied by everything. So minus 8 into minus half is 4, 6 into minus half is minus 3, minus 9 by 2 plus 7 by 2. And now we'll find this B inverse into A inverse. So we have B inverse this and A inverse this. We can simply multiply them. Let us see. Row multiplied by column. Never forget the rules. Okay. So minus 9 by 2 into minus 9 by 2 into 5 is minus 5 by 2. 4 into minus 2 is minus 8. Similarly, multiplying with second column, minus 9 by 2 into minus 7. 7 9 is 63 by 2. And then 4 into 3 is 12. So once you multiply with the first row, then we can do the same with the second row. So 7 by 2 into 5 is 35 by 2, and minus 3 into minus 2 is 6. Okay. Multiplying with second column, 7 by 2 into minus 7 is minus 49 by 2, and minus 3 3 is a minus 9. On taking LCM and solving, we'll get this. This is B inverse, A inverse. So we have so far calculated this RHS, and now we'll do this LHS. The answer should be same. It will be same. So for LHS you need to find A into B first, right? Once you find A into B, then only we'll find inverse for that A into B. So A into B. This is A according to the question. This is B. Multiplying this row with the column. 3 6 are 18, 7 7 are 49. See 18 plus 49. Multiplying with second column. 3 8 are 24, 7 9 are 63. Okay, 24 plus 63. 87 will do. And now second row's turn. So multiplied by first column, 12 plus 35, 47. Multiplied by second column, 16 plus 45, that is 61. This is AB. And now we'll find the inverse of this 2 by 2 matrix. How? First of all, calculate the determinant. Determinant is 67 into 61 minus 47 into 87. So 67 into 61 minus 87 into 47, 4087 minus 4089, that is minus 2. And now simply change the position, right, and change the sign. Okay, now you'll get AB inverse as 1 upon determinant AB, and this adjoint A. Change the position and change the sign, right? So now we can match our answer. We have got the answer. Here we have got minus 61 by 2. Here also it is minus 61 by 2. Minus half is outside, therefore. Here we have 87 by 2. Again minus half into minus 87 is 87 by 2. Minus half into minus 47 is 47 by 2. Minus half into 67 is minus 67 by 2. So everything is right. We have proved it. Okay. So question number 13. Something new to learn. I have seen this question in year 2016 Delhi paper, I guess, if I am correct. So this equation that is given here, this is called as characteristic equation. In higher maths it is called characteristic equation, right? So what is the quality of this equation? Simple. If you put the value of A in this equation, this A will satisfy it. Okay, and with the help of this characteristic equation we will find A inverse. So whenever it is said hence find A inverse, it means by using this equation you will find A inverse, not by the previous method. Otherwise we can find it very easily. 6 plus 1 7, so 1 by 7. Change the position to 3 and change the sign, isn't it? So don't do that, because here it is said hence find, right? Hence find means use this equation. So first of all we'll see what we can do here. This is 7i, not 71. First of all we'll find a square. A square means a into a. So 3 1 minus 1 2 multiplied by 3 1 minus 1 2. First row into first column, that is 9 minus 1, which will become 8 later on, and 3 1s are 3 plus 2, that is 5. Once you do it with first row, then we can do it with second row as well. So minus 1 into 3 is minus 3, and minus 2, that is minus 5. Multiplying with second column, minus 1 plus 4, that is 3. So this is a square, right? Putting it in this characteristic equation, I'm sorry. So this thing is giving me hard time. Okay. So a square, this is the value of a square, minus 5 into a plus 7 into I. So a is already given, right? I, we already know what is I. 5 3s are 15, 5 1s are 5, minus 5, 5 2s are 10. 8 minus 15 is minus 7, 5 minus 5 is 0, minus 5 plus 5 is 0, and 3 minus 10 is minus 7. This matrix as it is. Now we can see this matrix is negative of this matrix. On adding we'll get null matrix. Hence the equation is satisfied by the given matrix. So once it is done, how to find A inverse? Very simple. Always take this I term towards RHS. So we'll take this 7i towards RHS, right? 7i towards RHS. Always take I term towards RHS. Next, multiply the whole equation by A inverse. Multiply the whole equation by A inverse. So A square into A inverse, A into A inverse, I into A inverse. So what this A inverse will do? A square means there are two A's. So this A inverse will cancel this A. Okay, saying this is actually not correct, because there is no such thing as cancelling in matrices, but yes, we can say A into A inverse, A and A inverse will cancel each other. A and A inverse will cancel each other. Actually, A into A inverse is what you already know. It is I, okay, and I into A is A. So only A will be remaining here. Similarly, A into A inverse will be I, right? And this is only inverse. So here A into I, that is I, minus 5, A into I, that is A, 5 into I will be 5I, and 7 I into A inverse will be A inverse. So let us see, right? Okay. So let us proceed further. Now we can find A inverse easily. What we'll do now? We'll take this minus 7 towards LHS in the denominator. So minus 1 by 7, and this A into I will be A minus 5I. So A inverse is actually minus 1 by 7, A minus 5I. Sending this negative inside the bracket. So 5I will become positive and A will become negative. And now simply just put the value 5, 1001. 5 into 1001 will be 5005 minus value of A. Subtract them, and this is our A inverse. I hope everything is clear. The important part is this only. You always take I term towards RHS, then multiply by A inverse. A into A inverse is I into A is A into A inverse is I, and I into A inverse is A inverse. I behaves like 1. Simple, right? So 1 into 5 is 5. 1 into 10 is 10. Similarly, I into any matrix is same. So I into A will be A. I into A inverse will be A inverse. Okay. So these things we have already learned, but some students, they just start from this exercise only. They'll not watch the initial videos. So for them, it will be troublesome. Everything should be in a proper manner, in a proper sequence. If you break the sequence, it will cause problem to you. Okay, now question number 14. For a matrix this, find the number A and B such that this thing is 0. Right, so this time you need to find A and B. Okay, what is capital A square? It means matrix A multiplied by matrix A, row multiplied by column. 3 3s are 9 plus 2, that will be 11. Multiplying with second column, 3 2s are 6 plus 2, that is 8. Now second row, first column, 1 3s are 3, 1 1s are 1, 3 plus 1 is 4. Multiplying with second column, 2 plus 1, that is 3. Okay, so 11 plus 8, 4, 3, that is common thing for you. A square is not a big deal for you, right? Okay, we need to find small a and small b. So once you get this, okay, excuse me. Once you get this, multiply the whole equation by A inverse. So again, A square can be written as A into A. Here also A inverse and I into A inverse. 0 matrix into A inverse will be 0 only. So A into A inverse is capital I. Again capital I, that is identity. I into A inverse will be A inverse only. Taking this A inverse term towards RHS, and our A inverse is minus 1 by B, A plus AI. Got it? Minus 1 by B, A plus AI. Now, A inverse, as we already know, it is equal to 1 by determinant A, adjoint A. We already know this fact. So, what is determinant for this matrix? It is 3 minus 2, that is 1. So, 1 by determinant A, that is 1 by 1. And adjoint A, again, simple. Change the positions, 1, 3. And change the sign, that is minus 1, minus 2. So not a big deal. Okay, here it is. Okay, so A inverse, we know that it is equal to this, and from here A inverse is minus 1 by B, A plus AI, minus 1 by B, A means the question, plus A into I. A into identity is A00A. On adding this, we'll get 3 plus A, 2, 1 plus 0 is 1, 1 plus A is 1 plus A, minus 1 by B, sending this minus 1 by B inside, And now just equate this matrix with this matrix, isn't it? This is also A inverse, this is also A inverse. Just equate them and you'll get the value of A and B. Right. Okay, there is a simpler method also. I know you must be thinking there is a simple method also. Okay, you need not do all these things, finding A inverse and all. Simply you can solve it like this. A square is 11, 8, 4, 3. Okay, A square. And A into A means small a into matrix will be 3A, 2A, 1 into A, 1 into A, and then plus BI. So identity is 1 0, multiplying it with B will give you B 0 and 0 B. And what it is equal to? It is equal to 0 matrix. It means everything is 0. Every element of this matrix is 0. Now just simply add it. Okay. So this will be 11 plus 3A plus B. 11 plus 3A plus B. And what it is equal to? This is equal to 0. So you'll get one equation, right? Then for these elements, A plus 2A plus 0 is equal to 0. So 8 plus 2A is equal to 0. It means A is minus 4. You need not to be a great mathematician to know that A will be minus 4 from these elements. Once you put A is equal to minus 4 here, you will get B. B is 1. Let us check our answer. See. So various methods are there of doing the same question. Whatever you like, you can do by that method. Okay, let us proceed to question number 15. Again, we have a matrix here and we need to show that this whole thing is equal to 0. That is, this matrix satisfies this characteristic equation, and from there we'll find A inverse. So very good question. First of all, we need to find A square. A square is A into A. Okay, let us see. First row multiplied by first column. 1, 1, 2, that is 4. Multiplied by second. 1, 2, minus 1. That will be 2. And multiplying by third column. 1, minus 3, 3. 1 minus 3, 3 means it will be 1 only. Right? You can see here also. Then second row with first column. 1, 2, 3, minus 6, 3 minus 6 is minus 3. Multiplying with second column, 1, 4 plus 3, that is 8. And multiplying with third column, that is 1 minus 6 minus 9, that is minus 14. So this is also done. And now we'll go to the next row, multiplying with first column, 2 minus 1 plus 6, that will be 7. Multiplying with second column, 2 minus 2, 0, minus 3, so minus 3. Multiplying with third column, 2 plus 3, 5, plus 3, 3 is a 9, 9 plus 5 is 14. So this is our A square. Okay, so after getting A square, we'll focus on A cube. A cube is A square into A. So whatever A square you got, you put it here, then A, same multiplication, row into column, row into column, row into column, right? I'll not explain this time. This time you do it by yourself. Pause the video. After that, come and see. Everything is written here. So A cube is this. Right. Now, after getting A cube, A square, we'll put everything in this equation. So this is A cube that we have computed here. Then minus 6 into A square. In the previous step, we have computed it. Then 5 into A and then plus 11 into I. 6 into this whole thing will be 24, 12, 6, then minus 18, 48, 6 14 is 84, 7 6 are 42, 3 6 are 18, 14 6 are 84, right? See. 5 into this whole thing, 5, 5, 5, 5, 10, minus 15, 10, minus 5, 15. 11 into this whole thing will be 11, 11, 11 in the diagonal, a scalar matrix. Okay. Now let us subtract this first. Or How you want to do this? Add all the positive terms first. Okay, this you add up. 8 plus 5 plus 11 will be 24. 7 plus 5 plus 0 will be 12. 1 plus 5, 6 plus 0, that is 6. So some student straightforward write all these elements here. They know that this is going to be cancelled anyhow. So these elements must be equal to these elements, or this matrix must be equal to this matrix. But just for the beginning, you do all this calculation and you see these two matrices are equal. Otherwise, you can be smart in the exam and right away you can write these elements from this matrix. Okay, then on subtracting it will be 0. So this is not a big deal, satisfying the equation. And now just we need to we need to find A inverse from this equation. What we'll do, we'll take 11i towards that side and then multiply whole thing by A inverse. See, A cube into A inverse, A square into A inverse, A into A inverse. 11i, you can take it in first step or later on you can take it towards RHS. It doesn't matter. So A inverse into A will be I into A square will be A square, A into A inverse will be I into A will be A into A inverse will be and I into A inverse will be A inverse only. So minus 11 A inverse taken plus 11 A inverse taken towards RHS will become minus 11 A inverse. Taking this minus 11 towards the denominator in the LHS, so minus 1 by 11, this whole thing as it is, right? A square you have already computed, 6 into A given 5 into I. Simply 6 into this whole thing, 5 into this whole thing. Then add these up, this term with this, because these are positive matrices, or what you can do is subtract these terms and then add into it. It doesn't matter at all. So 4 plus 5 is 9, 2 plus 0 is 2 and 1 plus 0 is 1, minus 3 plus 0 is minus 3, 8 plus 5 is 13, minus 14 plus 0 is minus 14, 7 plus 0 is 7, minus 3 plus 0 is minus 3, 14 plus 5 is 19, and now subtract them, you'll get something, right? This is your A inverse, and okay, minus 1 by 11, here we haven't written it, but later on while writing A inverse we can write minus 1 by determinant A and everything that you computed earlier. Question 16, same question, I leave it for you. Why to waste your time? Time is precious, do it by yourself. If you don't get the answer, then come and see here, pause the video, see the solution where you are doing mistake. This is A square, right? Then A square into A will be A cube, and then satisfying this equation, A cube minus 6A square plus 9A minus 4I, solving everything, you'll get 0. Then multiply whole thing by A inverse, and similarly, similar to last question, you'll get A inverse, right? Let us not waste our time. Question number 7. A is a non-singular. Singular matrices are those matrices for which determinant is 0. Singular matrices are those matrices for which determinant is 0. And he's saying it is a non-singular square matrix, that the determinant is not 0, of order 3 by 3. Then adjointed determinant is always equal to determinant A raised to power n minus 1, where n is the order of the square matrix. So since the order of the square matrix is 3, so determinant A raised to power 3 minus 1, that is 2. Okay, this much is enough, no need for this proof. Further, question number 18, A is an invertible matrix. Invertible matrix, that means that its inverse can be calculated and determinant is not 0. Then determinant of A inverse is equal to 1 upon determinant A. So this is your answer, right? Straightforward, you can put this answer. Okay, so yes, 1 upon determinant. I guess the exercise is over. Very lengthy exercise, but very important as well. Kindly write everything, okay, and learn everything properly. If any doubt,